I always thought Java uses pass by reference. However, I've seen a couple of blog posts, for example, this blog, that claim that it isn't. The blog post says that Java uses pass by value. I don't think I understand the distinction they're making. What is the explanation? Java is always pass by value. Unfortunately, when we deal with objects, we are really dealing with object handles called references, which are passed by value as well. This terminology and semantics easily confuse many beginners. It goes like this. In the example above, a dog.getName will still return max. The value a dog within main is not changed in the function foo with the dog Fifi, as the object reference is passed by value. If it were passed by reference, then the a dog.getName in main would return Fifi after the call to foo. Likewise, in the above example, Fifi is the dog's name after call to foo a dog because the object's name was set inside of foo. Any operations that foo performs on D are such that, for all practical purposes, they are performed on a dog. But it is not possible to change the value of the variable a dog itself. I just noticed you referenced my article. The Java spec says that everything in Java is pass by value. There is no such thing as pass by reference in Java. The key to understanding this is that something like is not a dog. It's actually a pointer to a dog. The use of the term reference in Java is very misleading and is what causes most of the confusion here. What they call references act/feel more like what we'd call pointers in most other languages. What that means is when you have, you're essentially passing the address of the created dog object to the foo method. I say essentially because Java pointers/references aren't direct addresses. But it's easiest to think of them that way. Suppose the dog object resides at memory address 42. This means we pass 42 to the method. If the method were defined as, let's look at what's happening. The parameter SumDog is set to the value 42. At line AAA, SumDog is followed to the dog. It points to the dog object at address 42. That dog, the one at address 42, is asked to change his name to Max. At line BBB, a new dog is created. Let's say he's at address 74. We assign the parameter SumDog to 74. At line CCC, SumDog is followed to the dog. It points to the dog object at address 74. That dog, the one at address 74, is asked to change his name to Rolf. Then we return. Now let's think about what happens outside the method. Did my dog change? There's the key. Keeping in mind that my dog is a pointer and not an actual dog, the answer is no. My dog still has the value 42. It's still pointing to the original dog, but note that because of line AAA, its name is now Max. Still the same dog. My dog's value has not changed. It's perfectly valid to follow an address and change what's at the end of it. That does not change the variable. However, Java works exactly like C. You can assign a pointer, pass the pointer to a method, follow the pointer in the method and change the data that was pointed to. However, you cannot change where that pointer points. In C++, Ada, Pascal and other languages that support pass by reference, you can actually change the variable that was passed. If Java had pass by reference semantics, the foo method we defined above would have changed where my dog was pointing when it assigns SumDog on line BBB. Think of reference parameters as being aliases for the variable passed in. When that alias is assigned, so is the variable that was passed in. Java always passes arguments by value, not by reference. Let me explain this through an example. I will explain this in steps. Declaring a reference named f of type foo and assign it a new object of type foo with an attribute f. Foo f equals new foo f. From the method side, A reference of type foo with a name is declared and it's initially assigned null. Public static void change reference foo a. As you call the method change reference, the reference a will be assigned the object which is passed as an argument. Change reference f. Declaring a reference named b of type foo and assign it a new object of type foo with an attribute b. Foo b equals new foo b. A equals b makes a new assignment to the reference a, not f, of the object whose attribute is b. As you call modify reference foo c method, a reference c is created and assigned the object with attribute f. C.set attribute c will change the attribute of the object that reference c points to it. And it's the same object that reference f points to it. I hope you understand now how passing objects as arguments works in Java. This will give you some insights of how Java really works, to the point that in your next discussion about Java passing by reference or passing by value you'll just smile, smiley face. Step 1. Please erase from your mind that word that starts with p underscore 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 underscore. Especially if you come from other programming languages. Java and P cannot be written in the same book, forum, or even text. Step 2. Remember that when you pass an object into a method you're passing the object reference and not the object itself. Student. Master. Does this mean that Java is pass by reference? Master. Grasshopper. No. Now think of what an object's reference / variable does / is. A variable holds the bits that tell the JVM how to get to the referenced object in memory heap. When passing arguments to a method you are not passing the reference variable, but a copy of the bits in the reference variable. Something like this. 3bad086a. 3bad086a represents a way to get to the passed object. So you're just passing 3bad086a that it's the value of the reference. You're passing the value of the reference and not the reference itself and not the object. This value is actually copied and given to the method. In the following, please don't try to compile / execute this. What happens? The variable person is created in line number 1 and it's null at the beginning. A new person object is created in line number 2. Stored in memory. And the variable person is given the reference to the person object. That is, its address. Let's say 3bad086a. The variable person holding the address of the object is passed to the function in line number 3. In line number 4 you can listen to the sound of silence. Check the comment on line number 5. A method local variable, another reference to the same person object, is created, and then comes the magic in line number 6. The variable / reference person is copied bit by bit and passed to another reference to the same person object inside the function. No new instances of person are created. Both person and another reference to the same person object hold the same value of 3bad086a. Don't try this, but person == another reference to the same person object would be true. Both variables have identical copies of the reference and they both refer to the same person object. The same object on the heap and not a copy. A picture is worth 1,000 words. Note that the another reference to the same person object arrows is directed towards the object and not towards the variable person. If you didn't get it, then just trust me and remember that it's better to say that Java is pass by value. Well, pass by reference value. Oh well. Even better is pass by copy of the variable value. Winky face. Now feel free to hate me, but note that given this, there is no difference between passing primitive data types and objects. When talking about method arguments, you always pass a copy of the bits of the value of the reference. If it's a primitive data type, these bits will contain the value of the primitive data type itself. If it's an object, the bits will contain the value of the address that tells the JVM how to get to the object. Java is pass-by value because inside a method you can modify the referenced object as much as you want, but no matter how hard you try you'll never be able to modify the past variable that will keep referencing not p underscore 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 the same object no matter what. The change name function above will never be able to modify the actual content, the bit values of the past reference. In other words, change name cannot make person refer to another object. Of course you can cut it short and just say that Java is pass-by value. Java is always pass-by value. With no exceptions. Ever. So how is it that anyone can be at all confused by this? And believe that Java is pass-by reference? Or think they have an example of Java acting as pass-by reference? The key point is that Java never provides direct access to the values of objects themselves. In any circumstances, the only access to objects is through a reference to that object. Because Java objects are always accessed through a reference, rather than directly. It is common to talk about fields and variables and method arguments as being objects, when pedantically they are only references to objects. The confusion stems from this, strictly speaking, incorrect change in nomenclature. So, when calling a method for primitive arguments int, long, etc., the pass-by value is the actual value of the primitive. For example, 3. For objects, the pass-by value is the value of the reference to the object. So if you have do something foo and public void do something foo foo, the two foos have copied references that point to the same objects. Naturally, passing by value a reference to an object looks very much like and is indistinguishable in practice from passing an object by reference. Java passes references by value. So you can't change the reference that gets passed in. I feel like arguing about pass-by reference vs pass-by value is not super helpful. If you say Java is pass-by whatever reference/value, in either case, you're not provide a complete answer. Here's some additional information that will hopefully aid in understanding what's happening in memory. Crash course on stack/heap. Before we get to the Java implementation, values go on and off the stack in a nice orderly fashion, like a stack of plates at a cafeteria. Memory in the heap, also known as dynamic memory, is haphazard and disorganized. The JVM just finds space wherever it can, and frees it up as the variables that use it are no longer needed. Okay. First off, local primitives go on the stack. So this code results in this. When you declare and instantiate an object, the actual object goes on the heap. What goes on the stack? The address of the object on the heap. C++ programmers would call this a pointer. But some Java developers are against the word pointer. Whatever. Just know that the address of the object goes on the stack. Like so. An array is an object, so it goes on the heap as well. And what about the objects in the array? They get their own heap space, and the address of each object goes inside the array. So, what gets passed in when you call a method? If you pass in an object, what you're actually passing in is the address of the object. Some might say the value of the address, and some say it's just a reference to the object. This is the genesis of the holy war between reference and value proponents. What you call it isn't as important as that you understand that what's getting passed in is the address to the object. One string gets created and space for it is allocated in the heap, and the address to the string is stored on the stack and given the identifier his name. Since the address of the second string is the same as the first, no new string is created and no new heap space is allocated, but a new identifier is created on the stack. Then we call shout. A new stack frame is created and a new identifier name is created and assigned the address of the already existing string. So, value, reference. You say potato. Just to show the contrast, compare the following: C++ and Java. Snippets. In C++. Note, bad code, memory leaks. But it demonstrates the point. In Java. Java only has the two types of passing. By value for built-in types. And by value of the pointer for object types. Java passes references to objects by value. Basically, reassigning object parameters doesn't affect the argument. Example. Will print out ha, instead of null. The reason this works is because bar is a copy of the value of baz, which is just a reference to ha. If it were the actual reference itself, then foo would have redefined baz to null. I can't believe that nobody mentioned Barbara Liskov yet. When she designed CLU in 1974, she ran into this same terminology problem. And she invented the term call by sharing, also known as call by object sharing and call by object, for this specific case of call by value where the value is a reference. The crux of the matter is that the word reference in the expression pass by reference means something completely different from the usual meaning of the word reference in Java. Usually in Java, reference means a reference to an object. But the technical terms pass by reference / value from programming language theory is talking about a reference to the memory cell holding the variable, which is something completely different. In Java everything is reference. So when you have something like point pnt1 equals new point 0, 0, Java does following: creates new point object, creates new point reference and initialize that reference to point refer to on previously created point object. From here, through point object life, you will access to that object through pnt1 reference. So we can say that in Java you manipulate object through its reference. Java doesn't pass method arguments by reference, it passes them by value. I will use example from this site. Flow of the program. Creating two different point object with two different reference associated. As expected, output will be. On this line, pass by value goes into the play. References pnt1 and pnt2 are passed by value to the tricky method, which means that now yours references pnt1 and pnt2 have their copies named arg1 and arg2. So pnt1 and arg1 points to the same object. Same for the pnt2 and arg2. In the tricky method. Next, in the tricky method, here, you first create new temp point reference which will point on same place like arg1 reference. Then you move reference arg1 to point to the same place like arg2 reference. Finally arg2 will point to the same place like temp. From here scope of tricky method is gone and you don't have access anymore to the references arg1, arg2, temp. But important note is that everything you do with these references when they are in life will permanently affect object on which they are point to. So after executing method tricky, when you return to main, you have this situation. So now, completely execution of program will be. Java is always pass by value, not pass by reference. First of all, we need to understand what pass by value and pass by reference are. Pass by value means that you are making a copy in memory of the actual parameter's value that is passed in. This is a copy of the contents of the actual parameter. Pass by reference, also called pass by address, means that a copy of the address of the actual parameter is stored. Sometimes Java can give the illusion of pass by reference. Let's see how it works by using the example below. The output of this program is change value. Let's understand step by step. As we all know, it will create an object in the heap and return the reference value back to t. For example, suppose the value of t is 0x100234. We don't know the actual JVM internal value. This is just an example. When passing reference t to the function, it will not directly pass the actual reference value of object test. but it will create a copy of t and then pass it to the function. Since it is passing by value, it passes a copy of the variable rather than the actual reference of it. Since we said the value of t was 0x100234, both t and f will have the same value and hence they will point to the same object. If you change anything in the function using reference f, it will modify the existing contents of the object. That is why we got the output change value, which is updated in the function. To understand this more clearly, consider the following example. Will this throw a null pointer exception? No. Because it only passes a copy of the reference. In the case of passing by reference, it could have thrown a null pointer exception, as seen below. Hopefully this will help. There are already great answers that cover this. I wanted to make a small contribution by sharing a very simple example, which will compile contrasting the behaviors between pass by reference in C++ and pass by value in Java. A few points. The term reference is overloaded with two separate meanings. In Java it simply means a pointer. But in the context of pass by reference it means a handle to the original variable which was passed in. Java is pass by value. Java is a descendant of C among other languages. Before C, several but not all earlier languages like Fortran and COBOL supported PBR. But C did not. PBR allowed these other languages to make changes to the passed variables inside subroutines. In order to accomplish the same thing, i.e., change the values of variables inside functions, C programmers passed pointers to variables into functions. Languages inspired by C, such as Java, borrowed this idea and continue to pass pointer to methods as C did. Except that Java calls its pointers references. Again, this is a different use of the word reference than in pass by reference. C++ allows pass by reference by declaring a reference parameter using the end character, which happens to be the same character used to indicate the address of a variable in both C and C++. For example, if we pass in a pointer by reference, the parameter and the argument are not just pointing to the same object. Rather, they are the same variable. If one gets set to a different address or to null, so does the other. In the C++ example below, I'm passing a pointer to a null terminated string by reference. And in the Java example below, I'm passing a Java reference to a string again. The same as a pointer to a string by value. Notice the output in the comments. C++ pass by reference example. Java pass a Java reference by value example. Edit. Several people have written comments which seem to indicate that either they are not looking at my examples or they don't get the C++ example. Not sure where the disconnect is, but guessing the C++ example is not clear. I'm posting the same example in Pascal because I think pass by reference looks cleaner in Pascal. But I could be wrong. I might just be confusing people more. I hope not. In Pascal, parameters passed by reference are called var parameters. In the procedure set to nil below, please note the keyword var which precedes the parameter ptr. When a pointer is passed to this procedure, it will be passed by reference. Note the behavior. When this procedure sets ptr to nil, that's Pascal speak for null. It will set the argument to nil. You can't do that in Java. Edit 2. Some excerpts from The Java Programming Language by Ken Arnold, James Gosling, the guy who invented Java, and David Holmes. Chapter 2. Section 2.6.5. All parameters to methods are passed by value. In other words, values of parameter variables in a method are copies of the invoker, specified as arguments. He goes on to make the same point regarding objects. You should note that when the parameter is an object reference, it is the object reference, not the object itself, that is passed by value. And towards the end of the same section he makes a broader statement about Java being only pass by value and never pass by reference. The Java programming language does not pass objects by reference. It passes object references by value. Because two copies of the same reference refer to the same actual object. Changes made through one reference variable are visible through the other. There is exactly one parameter passing mode pass by value, and that helps keep things simple. This section of the book has a great explanation of parameter passing in Java and of the distinction between pass by reference and pass by value, and it's by the creator of Java. I would encourage anyone to read it, especially if you're still not convinced. I think the difference between the two models is very subtle, and unless you've done programming where you actually used pass by reference, it's easy to miss where two models differ. I hope this settles the debate. But probably won't. Edit 3. I might be a little obsessed with this post. Probably because I feel that the makers of Java inadvertently spread misinformation. If instead of using the word reference for pointers they had used something else, say dingleberry, there would have been no problem. You could say Java passes dingleberries by value and not by reference, and nobody would be confused. That's the reason only Java developers have issue with this. They look at the word reference and think they know exactly what that means. So they don't even bother to consider the opposing argument. Anyway, I noticed a comment in an older post, which made a balloon analogy which I really liked. So much so that I decided to glue together some clip art to make a set of cartoons to illustrate the point. Passing a reference by value. Changes to the reference are not reflected in the caller's scope, but the changes to the object are. This is because the reference is copied. But both the original and the copy refer to the same object. Pass by reference. There is no copy of the reference. Single reference is shared by both the caller and the function being called. Any changes to the reference or the object's data are reflected in the caller's scope. Edit 4. I have seen posts on this topic which describe the low-level implementation of parameter passing in Java, which I think is great and very helpful because it makes an abstract idea concrete. However, to me the question is more about the behavior described in the language specification than about the technical implementation of the behavior. This is an excerpt from the Java language specification, section 8.4.1. When the method or constructor is invoked 15.12. The values of the actual argument expressions initialize newly created parameter variables, each of the declared type, before execution of the body of the method or constructor. The identifier that appears in the declarator ID may be used as a simple name in the body of the method or constructor to refer to the formal parameter. Which means Java creates a copy of the past parameters before executing a method. Like most people who studied compilers in college, I used the Dragon book, which is the compiler's book. It has a good description of call by value and call by reference in chapter 1. The call by value description matches up with Java specs exactly. Back when I studied compilers in the 90s, I used the first edition of the book from 1986, which predated Java by about 9 or 10 years. However, I just ran across a copy of the second edition from 2007, which actually mentions Java. Section 1.6.6 labeled Parameter Passing Mechanisms describes parameter passing pretty nicely. Here is an excerpt under the heading Call by Value which mentions Java. In call by value, the actual parameter is evaluated if it is an expression or copied if it is a variable. The value is placed in the location belonging to the corresponding formal parameter of the called procedure. This method is used in C and Java, and is a common option in C++, as well as in most other languages. Java is a call by value. How it works. You always pass a copy of the bits of the value of the reference. If it's a primitive data type, these bits contain the value of the primitive data type itself. That's why if we change the value of header inside the method, then it does not reflect the changes outside. If it's an object data type like foo equals new foo, then in this case copy of the address of the object passes like file shortcut. Suppose we have a text file abc.txt at c:\desktop, and suppose we make shortcut of the same file and put this inside c:\desktop\abc- shortcut, so when you access the file from c:\desktop\abc.txt and write Stack Overflow and close the file, and again you open the file from shortcut, then you write is the largest online community for programmers to learn, then total file change will be Stack Overflow is the largest online community for programmers to learn, which means it doesn't matter from where you open the file. Each time we were accessing the same file. Here we can assume foo as a file, and suppose foo stored at 123 HD7 original address like c:\desktop\abc.txt address and 234 JDID copied address like c:\desktop\abc- shortcut, which actually contains the original address of the file inside. So for better understanding, make shortcut file and feel. A reference is always a value when represented. No matter what language you use. Getting an outside of the box view. Let's look at assembly or some low-level memory management. At the CPU level, a reference to anything immediately becomes a value if it gets written to memory or to one of the CPU registers. That is why pointer is a good definition. It is a value which has a purpose at the same time. Data in memory has a location. And at that location there is a value byte word. Whatever. In assembly we have a convenient solution to give a name to certain location, aka variable. But when compiling the code, the assembler simply replaces name with the designated location, just like your browser replaces domain names with IP addresses. Down to the core, it is technically impossible to pass a reference to anything in any language without representing it when it immediately becomes a value. Let's say we have a variable foo. Its location is at the 47th byte in memory and its value is 5. We have another variable, ref2 foo, which is at 223rd byte in memory, and its value will be 47. This ref2 foo might be a technical variable, not explicitly created by the program. If you just look at 5 and 47 without any other information, you will see just two values. If you use them as references, then to reach to 5 we have to travel. This is how jump tables work. If we want to call a method /function /procedure with foo's value, there are a few possible ways to pass the variable to the method, depending on the language and its several method invocation modes. 5 gets copied to one of the CPU registers, i.e. EAX. 5 gets PUSHD to the stack. 47 gets copied to one of the CPU registers. 47 PUSHD to the stack. 223 gets copied to one of the CPU registers. 223 gets PUSHD to the stack. In every cases above, a value copy of an existing value has been created. It is now up to the receiving method to handle it. When you write foo inside the method, it is either read out from EAX or automatically differentiated or double differentiated. The process depends on how the language works and / or what the type of foo dictates. This is hidden from the developer until she circumvents the differentiating process. So a reference is a value when represented, because a reference is a value that has to be processed at language level. Now we have passed foo to the method. In case 1 and 2, If you change foo equals 9, it only affects local scope as you have a copy of the value. From inside the method we cannot even determine where in memory the original foo was located. In case 3 and 4, if you use default language constructs and change foo equals 11, it could change foo globally depends on the language, i.e. Java or like Pascal's procedure find minx y z integer var m integer. However, if the language allows you to circumvent the dereference process, you can change 47, say to 49. At that point foo seems to have been changed if you read it, because you have changed the local pointer to it. And if you were to modify this foo inside the method foo equals 12, you will probably foobar the execution of the program, aka seg fault, because you will write to a different memory than expected. You can even modify an area that is destined to hold executable program, and writing to it will modify running code. Foo is now not at 47. But foo's value of 47 did not change globally. Only the one inside the method. Because 47 was also a copy to the method. In case 5 and 6, if you modify 223 inside the method, it creates the same mayhem as in 3 or 4. A pointer pointing to a now bad value. That is again used as a pointer, but this is still a local problem, as 223 was copied. However, if you are able to dereference ref2 foo, that is 223, reach to and modify the pointed value 47, say, to 49, it will affect foo globally. Because in this case the method's got a copy of 223, but the referenced 47 exists only once. And changing that to 49 will lead every ref2 foo double dereferencing to a wrong value. Nitpicking on insignificant details. Even languages that do pass by reference will pass values to functions. But those functions know that they have to use it for dereferencing purposes. This pass the reference as value is just hidden from the programmer because it is practically useless, and the terminology is only pass by reference. Strict pass by value is also useless. It would mean that a 100-byte array should have to be copied every time we call a method with the array as argument. Therefore Java cannot be strictly pass by value. Every language would pass a reference to this huge array as a value, and either employs copy on write mechanism if that array can be changed locally inside the method, or allows the method as Java does to modify the array globally from the caller's view, and a few languages allows to modify the value of the reference itself. So in short, and in Java's own terminology, Java is pass by value where value can be either a real value or a value that is a representation of a reference. As far as I know, Java only knows call by value. This means for primitive data types you will work with an copy, and for objects you will work with an copy of the reference to the objects. However, I think there are some pitfalls. For example, this will not work. This will populate hello world and not world hello, because in the swap function you use copies which have no impact on the references in the main. But if your objects are not immutable, you can change it. For example, this will populate hello world on the command line. If you change string buffer into string, it will produce just hello because string is immutable. For example. However, you could make a wrapper for string like this which would make it able to use it with strings. Edit. I believe this is also the reason to use string buffer when it comes to adding two strings, because you can modify the original object, which you can't with immutable objects like string is. No. It's not pass by reference. Java is pass by value according to the Java language specification. When the method or constructor is invoked 15.12. The values of the actual argument expressions initialize newly created parameter variables, each of the declared type, before execution of the body of the method or constructor. The identifier that appears in the declarator ID may be used as a simple name in the body of the method or constructor to refer to the formal parameter. Let me try to explain my understanding with the help of 4 examples. Java is pass by value, and not pass by reference. Pass by value. In Java, all parameters are passed by value, i.e., assigning a method argument is not visible to the caller. */ Example 1. Result. Example 2. / asterisk pass by value asterisk / result. Example 3. / This pass by value has a feeling of pass by reference. Some people say primitive types and string are pass by value, and objects are pass by reference. But from this example, we can understand that it is in fact pass by value only. Keeping in mind that here we are passing the reference as the value, i.e., reference is passed by value. That's why are able to change and still it holds true after the local scope. But we cannot change the actual reference outside the original scope. What that means is demonstrated by next example of pass by value object case 2. */ result. Example 4. / In addition to what was mentioned in example 3 pass by value object case 1. Java. We cannot change the actual reference outside the original scope. Note: I am not pasting the code for private class student. The class definition for student is same as example 3. */ result. You can never pass by reference in Java. And one of the ways that is obvious is when you want to return more than one value from a method call. Consider the following bit of code in C++. Sometimes you want to use the same pattern in Java, but you can't. At least not directly. Instead you could do something like this. As was explained in previous answers. In Java you're passing a pointer to the array as a value into getValues. That is enough. Because the method then modifies the array element. And by convention you're expecting element 0 to contain the return value. Obviously you can do this in other ways. Such as structuring your code so this isn't necessary. Or constructing a class that can contain the return value or allow it to be set. But the simple pattern available to you in C++ above is not available in Java. I thought I'd contribute this answer to add more details from the specifications. First, what's the difference between passing by reference versus passing by value? Passing by reference means the called function's parameter will be the same as the caller's passed argument, not the value, but the identity, the variable itself. Pass by value means the called function's parameter will be a copy of the caller's passed argument. Or from Wikipedia. On the subject of pass by reference. In call by reference evaluation, also referred to as pass by reference, a function receives an implicit reference to a variable used as argument, rather than a copy of its value. This typically means that the function can modify, i.e., assign to the variable used as argument something that will be seen by its caller. And on the subject of pass by value, in call by value, the argument expression is evaluated, and the resulting value is bound to the corresponding variable in the function. If the function or procedure is able to assign values to its parameters, only its local copy is assigned. Second, we need to know what Java uses in its method invocations. The Java language specification states, when the method or constructor is invoked 15.12, the values of the actual argument expressions initialize newly created parameter variables, each of the declared type, before execution of the body of the method or constructor. So it assigns or binds the value of the argument to the corresponding parameter variable. What is the value of the argument? Let's consider reference types. The Java Virtual Machine Specification states, there are three kinds of reference types: class types, array types, and interface types. Their values are references to dynamically created class instances, arrays, or class instances or arrays that implement interfaces, respectively. The Java language specification also states, the reference values, often just references, are pointers to these objects, and a special null reference, which refers to no object. The value of an argument of some reference type is a pointer to an object. Note that a variable, an invocation of a method with a reference type return type, and an instance creation expression new, all resolve to a reference type value. So, all bind the value of a reference to a string instance to the method's newly created parameter, param. This is exactly what the definition of pass-by-value describes. As such, Java is pass-by-value. The fact that you can follow the reference to invoke a method or access a field of the referenced object is completely irrelevant to the conversation. The definition of pass-by reference was. This typically means that the function can modify, i.e., assign to the variable used as argument something that will be seen by its caller. In Java, modifying the variable means reassigning it. In Java, if you reassign the variable within the method, it would go unnoticed to the caller. Modifying the object referenced by the variable is a different concept entirely. Primitive values are also defined in the Java Virtual Machine specification. Here, the value of the type is the corresponding integral or floating point value, encoded appropriately 8, 16, 32, 64, etc. bits. In Java, only references are passed and are passed by value. Java arguments are all passed by value. The reference is copied when used by the method. In the case of primitive types, Java behavior is simple. The value is copied in another instance of the primitive type. In case of objects, this is the same. Object variables are pointers buckets holding only objects. Address that was created using the new keyword, and are copied like primitive types. The behavior can appear different from primitive types, because the copied object variable contains the same address to the same object. Objects, content/members, might still be modified within a method and later access outside, giving the illusion that the containing object itself was passed by reference. String objects appear to be a good counterexample to the urban legend saying that objects are passed by reference. In effect, using a method, you will never be able to update the value of a string passed as argument. A string object holds characters by an array declared final that can't be modified. Only the address of the object might be replaced by another using new. Using new to update the variable will not let the object be accessed from outside, since the variable was initially passed by value and copied. The distinction, or perhaps just the way I remember as I used to be under the same impression as the original poster, is this: Java is always pass by value. All objects in Java, anything except for primitives in Java, are references. These references are passed by value. As many people mentioned it before, Java is always pass by value. Here is another example that will help you understand the difference. The classic swap example. Prints before A equals 2, B equals 3. After A equals 2, B equals 3. This happens because IA and IB are new local reference variables that have the same value of the past references they point to A and B respectively. So, trying to change the references of IA or IB will only change in the local scope and not outside of this method. Unlike some other languages, Java does not allow you to choose between pass-by-value and pass-by-reference. All arguments are passed by value. A method call can pass two types of values to a method: copies of primitive values, example, values of int and double, and copies of references to objects. When a method modifies a primitive type parameter, changes to the parameter have no effect on the original argument value in the calling method. When it comes to objects, objects themselves cannot be passed to methods. So we pass the reference address of the object. We can manipulate the original object using this reference. How Java creates and stores objects. When we create an object, we store the object's address in a reference variable. Let's analyze the following statement. Account1 is the type and name of the reference variable. Equals is the assignment operator. New asks for the required amount of space from the system. The constructor to the right of keyword new, which creates the object, is called implicitly by the keyword new. Address of the created object, result of write value, which is an expression called class instance creation expression, is assigned to the left value, which is a reference variable with a name and a type specified using the assign operator. Although an object's reference is passed by value, a method can still interact with the referenced object by calling its public methods using the copy of the object's reference. Since the reference stored in the parameter is a copy of the reference that was passed as an argument, the parameter in the called method and the argument in the calling method refer to the same object in memory. Passing references to arrays instead of the array objects themselves makes sense for performance reasons. Because everything in Java is passed by value, if array objects were passed, a copy of each element would be passed. For large arrays, this would waste time and consume considerable storage for the copies of the elements. In the image below you can see we have two reference variables. These are called pointers in C/C++. And I think that term makes it easier to understand this feature. In the main method, primitive and reference variables are kept in stack memory left side in images below. Array1 and Array2 reference variables point as C/C++ programmers call it, or reference to A and B arrays respectively, which are objects' values. These reference variables hold are addresses of objects in heap memory right side in images below. If we pass the value of Array1 reference variable as an argument to the reverse array method, a reference variable is created in the method and that reference variable starts pointing to the same array A. So, if we say, in reverse array method, it will make a change in array A. We have another reference variable in reverse array method Array2 that points to an array C. If we were to say, in reverse array method, then the reference variable Array1 in method reverse array would stop pointing to array A and start pointing to array C. Dotted line in second image. If we return value of reference variable Array2 as the return value of method reverse array and assign this value to reference variable Array1 in main method, Array1 in main will start pointing to array C. So let's write all the things we have done at once now. And now that reverse array method is over, its reference variables Array1 and Array2 are gone. Which means we now only have the two reference variables in main method Array1 and Array2, which point to C and B arrays respectively. No reference variable is pointing to object array A, so it is eligible for garbage collection. You could also assign value of Array2 in main to Array1. Array1 would start pointing to B. I always think of it as pass by copy. It is a copy of the value, be it primitive or reference. If it is a primitive, it is a copy of the bits that are the value, and if it is an object, it is a copy of the reference. Output of Java pass by copy. Name equals max. Name equals Fido. Primitive wrapper classes and strings are immutable, so any example using those types will not work the same as other types/objects. Java has only pass by value. A very simple example to validate this. I have created a thread devoted to these kind of questions for any programming languages. Here, Java is also mentioned. Here is the short summary. Java passes it parameters by value. By value is the only way in Java to pass a parameter to a method. Using methods from the object given as parameter will alter the object as the references point to the original objects. If that method itself alters some values. To make a long story short, Java objects have some very peculiar properties. In general, Java has primitive types int, bool, char, double, etc. that are passed directly by value. Then Java has objects, everything that derives from java.lang.object. Objects are actually always handled through a reference being a pointer that you can't touch. That means that in effect, objects are passed by reference. As the references are normally not interesting. It does however mean that you cannot change which object is pointed to as the reference itself is passed by value. Does this sound strange and confusing? Let's consider how C implements pass by reference and pass by value. In C, the default convention is pass by value. Void fooint x passes an int by value. Void fooint *x is a function that does not want an int a, but a pointer to an int. Foona. One would use this with the AND operator to pass a variable address. Take this to C++. And we have references. References are basically in this context syntactic sugar that hide the pointer part of the equation. Void fooint and x is called by fooa, where the compiler itself knows that it is a reference and the address of the non-references should be passed. In Java, all variables referring to objects are actually of reference type. In effect forcing call by reference for most intents and purposes without the fine-grained control and complexity afforded by, for example,